Hello friends, welcome to this video session. The topic that we are going to cover in this session is chemical properties of metals. Metals show different chemical properties. Let's begin and study them one by one. The first chemical property of metals that we are going to discuss is reaction of metals with oxygen from air. When metals are burnt in air, they react with oxygen from the air to form metal oxides. These metal oxides are basic in nature and therefore they will turn red litmus solution blue. The vigor of reaction with oxygen depends on the chemical reactivity of metals. Highly reactive metals react at room temperature. A less reactive metal will react on heating, whereas still other metals react on strong heating. For example, 1. Sodium metal reacts with the oxygen of air at room temperature to form basic oxide called sodium oxide. 2. Potassium metal also reacts with oxygen of air at room temperature to form basic oxide, potassium oxide, K2O. There is also an interesting fact about these metals. That is, potassium and sodium are so reactive that they react vigorously with oxygen present in air. They catch fire and start burning when kept open in the air, and this is the reason why they are stored under kerosene oil to prevent their reaction with the oxygen, moisture and carbon dioxide of air. The metal oxides formed in these reactions are mostly insoluble in water. But some of the metal oxides dissolve in water and they are known as alkalis. For example, sodium oxide is soluble in water and dissolves in water to produce sodium hydroxide, which is an alkali. Magnesium metal does not react with oxygen at room temperature, but on heating, it burns in air, giving intense heat and light to form a basic oxide called magnesium oxide, which is a white powder. Since it required heat for the reaction to occur, therefore, it is less reactive than sodium and potassium. And also, the product is magnesium oxide, which is partially soluble in water, so it is a base. Aluminium metal burns in air on heating to form aluminium oxide. Although most metal oxides are basic in nature, but some of the metal oxides show basic as well as acidic nature. Such metal oxides are known as amphoteric oxides. Iron and copper metal do not burn in air even on strong heating. The reaction of copper with oxygen takes place less readily than that of iron. Silver and gold metals do not react with oxygen even at high temperature, so they are still less reactive. The next, second chemical property that we are about to study is the reaction of metals with water. Metals react with water to form metal oxide and hydrogen gas. Although all metals do not react with water, the intensity of reaction of a metal with water depends on its chemical reactivity. Some metals react with cold water. Some react with hot water. Some react only with steam, whereas some do not even react with steam. A. When a metal reacts with water, hot or cold, then the products formed are metal hydroxide and hydrogen gas. B. When a metal reacts with steam, then the products are metal oxide and hydrogen gas. Potassium and sodium react vigorously with cold water and these reactions are exothermic in nature, and hydrogen gas formed during the reaction catches fire and burns, causing little explosions. Calcium reacts with cold water to form calcium hydroxide and hydrogen gas. The heat produced in this reaction is less, which is not sufficient for the hydrogen to catch fire. Magnesium metal does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen gas. Aluminium reacts with steam to form aluminium oxide and hydrogen gas. Zinc reacts with steam to form zinc oxide and hydrogen gas. Red hot iron reacts with steam to form iron oxide and hydrogen gas. On the basis of the vigor of their reaction with steam, we can arrange magnesium, aluminium, zinc and iron metals in the decreasing order of their reactivity. The next property that we are about to study is reaction of metals with dilute acids. Metals usually displace hydrogen from dilute acids. Only less reactive metals like copper, silver, gold do not displace hydrogen from dilute acids. When a metal reacts with a dilute acid, then a metal salt and hydrogen gas are formed. All the metals do not react with dilute acids. The vigor of reaction of a metal with dilute acid depends on its chemical reactivity. Metals react with dilute hydrochloric acid to give metal chlorides and hydrogen gas. Sodium metal reacts violently with dilute hydrochloric acid to form sodium chloride and hydrogen. This reaction shows that sodium is very reactive. Magnesium also reacts quite rapidly with dilute hydrochloric acid, forming magnesium chloride and hydrogen gas. Aluminium metal at first reacts slowly with dilute hydrochloric acid due to presence of a tough protective layer of aluminium oxide on its surface. But when the thin outer oxide layer gets dissolved in acid, then fresh metal is exposed and reacts rapidly with dilute hydrochloric acid. Zinc also reacts with dilute acid to give zinc chloride and hydrogen gas, but the reaction is less rapid than that of aluminium. Iron reacts with dilute acid to give iron chloride and hydrogen gas. Copper metal does not react with dilute hydrochloric acid or sulfuric acid, and this shows that copper is least reactive. From this, we can conclude that the reactivity decreases in this order. In this video, we studied the chemical properties of metals.